Okay, so hello everyone. I'm Nenad Pečanac. I come from Serengeti. We are primarily Java-based company. We do a lot of Java EE and Spring enterprise applications. Today we will talk about new incarnation of JavaScript. The last one was 5.1 and it was in 2009, so that was 6 years ago, which leaves enough time to present a whole lot of new features. Actually, there are far too many features to talk about in half an hour, so we'll just skip to the most interesting ones. This is our today's agenda. We'll talk briefly about history. We'll say something about tooling, and of course syntax, functions, classes, and all other nice features we're about to see in ES6 6. So let's talk some about history. So if anyone doesn't know here, JavaScript was created in 1995 by Brendan Eich. It was done in about 1 week, so that was far less time than required to develop a serious language. But language came out to be really influential and quickly gained popularity, which caused it to be shipped and really quickly accepted. It was also renamed from Mocha to JavaScript. That was a marketing move. Netscape had to do that to attract more attention to their new language because of the race with Microsoft. And that name, unfortunately, caused a significant misunderstanding of the language. You probably heard Douglas Crockford's talk about the good parts and all of that. So here we are. We have an incomplete language, and in JavaScript 5 we had an attempt to correct all the errors, like silent errors, which caused a lot of fuss in development. And in ECMAScript 6 a lot of new features were added to extend the language. So the version 5 repaired it and the version 6 enhanced it, or at least that's what they're trying to do. Some more of a history. We had browser wars, Microsoft against Netscape. It eventually ended that in a way that Netscape released their browser as open source, and today we have Mozilla Foundation, we have Mozilla Firefox, and well, we have some other browsers like Chrome, Opera, and others, and we have a standard called ECMAScript. The standard was developed in a way that Netscape decided that they can't compete with Microsoft, and so they decided to standardize the language. Microsoft had their own version called JScript. So the compromise was made, and today we have ECMAScript. This is the brief history shown in a quick table. So you probably know all of this, but we won't go into too much details right now. So maybe it was worth mentioning that version 4 was really ambitious project, but it was decided to abandon. It was abandoned due to political differences and due to significant language complexity, which just wasn't appropriate considering the current state of the language back then. It was there were a lot of things to be fixed, so they decided not to do that. They decided to first fix the language with version 5 and then to enhance it with version 6. So breaking the web was minimal. So in release 5 in 2009 we had strict mode. That is, we still have it. It's still in use. So strict mode presented a subset intended to provide more thorough error checking, avoid error-prone constructs, famous mistakes, and all other stuff. 5.1 was aligned with third edition of this standard. and version 6 was released officially in June 2015, and the code name was ES6 Harmony. Version 7 is still in progress. Okay, before I say something about tooling, it's worth mentioning that current support, we'll see that at the end of the presentation when we talk about future and what's coming. Current support is not complete. Standard was in June 2015, but all the major browsers are still working on the support, and until that happens, we can use transpilers, which we will talk about here. Okay. So JavaScript to JavaScript transpiler is currently required to run ES6. So what does it mean? Well, just look at the picture. It means that you write the newest code and you compile it to the previous version of the code. So why do we do this? We do this because it's the only way to guarantee that all the other browsers, even the old ones, are capable of running our new code. Of course, it's not so, I mean, it's not really black and white situation. Some old browsers will not work and some will with new features. So, but these transpilers are highly configurable tools. One of the most popular transpilers is Babel, and it provides a way to use a bunch of plugins, to even write your own plugins, and to really fine customize the transpiling process. You can choose what you want to translate and what you want to leave, etc. And of course, it provides human readable output, so this transpiled code that you get is not just some blurred compiled JavaScript no one can read. You can easily read it. It's understandable. So it's a great tool to write new code in current browsers. Of course, it doesn't just provide transpiling from ES6 to ES5. It is intended as a future tool to work with all new editions of the language. So when we have support for ECMAScript 6, we won't have support for ECMAScript 7, but we will be able to use it with these tools like Babel. Okay, so now we will talk about some of the features. Let and const are constructs which are alternatives to var when declaring variables. Let is block scoped instead of lexically scoped to a function. What this means? This means that you can choose scoping for your variables. In this example, you see variable I, and it is used in a common for loop. What is great about this is that you can reuse the variable I in some other loop, because you see it console log will show undefined. So this variable, because of the let, is defined only in the scope of this for loop. In this way we can reuse variables, and we have actually good control over our code. We don't have to worry about scoping. We can explicitly define it. Const is also block scope, and it's a new way to define constants. As we see in this example, we define a constant myConstant and we initialize it with the value 1. If we try to reinitialize it or change its value, it will throw an error. So we are not allowed to do that. So finally, in JavaScript, we have real constants. Of course, there had to be something not working quite as one would expect it. So if we have constant objects, we can still change its properties. That's just the way it is. You can like it or not, but it's easy to remember it, so I don't think it's very much of a deal. Okay, so in ES6 we have template strings, like in some other languages, Perl, Python, Ruby, etc. It's a simple way to use templating without string concatenation. So here's an example, hello, and we have what's it called in English? Placeholder, yes. Thank you. Okay, the above example shows how to split strings into few lines. We use this apostrophe mark to do that. So we still have some other features with strings, but these are, let's say, the most prominent ones. Okay, so destructuring is a technique that provides binding with pattern matching, and it will support matching for arrays and objects. So in this example with array matching, we see how we defined an array, and then we can assign that array to another array with omitting some of the members, which are simply left undefined and no error is shown. So this is intended behavior. You can easily match whatever you like. You can even easily swap variables, like in the third example here. So you see variables are easily swapped. We also have fail soft matching, which means that we will get silent errors doing this because we assigned an empty array to variable missing, and it will simply be undefined. So this syntax presumes that we know what we are doing. So that is the price we pay for getting a really powerful tool like this. So we still have silent errors, but they are by design. In another example, we have object matching. We see a couple of objects and how the same things works with objects. It's a fairly simple and really useful tool. We can even do destructuring in with method parameters and so on. And well, the list of features is too long to put in one slide, but I believe you get the picture. Okay, so object literals are extended with several new features. We have syntax for getting and setting the prototype object. Before this was something that some browsers implemented, some didn't, and all of them did it in their own ways. So now we have a standard way to get to the prototype of the object. We have handlers. Handler is a way to define a property which has the same value as it has its name. So the handler in this example means handler column semicolon handler. So it's just a shorter way to write that. We can also put methods directly into the object, and we can call a superclass inside the object definition. We can also do computed property names. We can write an expression and it will be evaluated and set as the name of this object. Okay, so now we'll talk about functions, which are the most powerful feature of the language. So in ECMAScript 6, we finally have arrow functions like in other languages, like in Java 8 and others. Arrows are function shorthand for this syntax. Parameter is used in return value. So return value is body of this arrow function. So these are some, here are some examples for if anyone doesn't know. So the map function is events is actually an array, and map returns an array in a way that it runs this function, this arrow function, on each member of the array. So when you run that, you get an array with just odd members. Similarly, in nums, you get array with members increased by I. In the third example, you get pairs. You get an array of objects with even and odd pairs. So I don't know if you understood anything I said, but if anyone wants, I can repeat and try to explain a little bit better. Okay. So in statement bodies, we can use also error functions in statement bodies like this. So for each is a new function introduced in ECMAScript 5, and well, it just applies this this arrow function to each member of the array. So basically, every fifth member divisible by 5 is pushed to the 5's array. Anyway, what we get with arrow functions are well, arrow functions are nice and direct implementation of lambda calculus inside the language. So this is what is so great, and we get a full access to functional programming, and it is really well supported in JavaScript. It was supported from the beginning of the language, but this is the more elegant way to do it, and actually proper way. There is one more significant feature of the language, and this is the correct scoping for error functions. So error functions do not get their own scope every time, but they receive a scope from the containing objects. So we do not have to use the self or that trick to get to the reference of the object containing the function. And it really enables us to write easier and more readable code. Classes are completely new in the language, and they are basically a syntactical sugar over the prototype-based object-oriented pattern. So we do not have new support in our JavaScript compilers entirely for classes. We use compilers use the code as they did before, but we can just write it in a more elegant way. They are, of course, well-debated feature of ES6, because part of the developers believe that they go against the nature of the language itself and that they shouldn't have been introduced, while others think that this will lower the entry barrier for beginners and that people will more easily adapt to JavaScript. They simply can write Java code into JavaScript and it will be fine. So this is a matter of opinion. Whether you like classes or whether you like prototypes, now you can do both, so it's up to you what you will use. This is one example of class. As you see, it's pretty common, nothing new here. We have a constructor, we have member variables, we have getter setters, and we create an instance like we do in other languages. In ECMAScript 6, we finally have support for collections, which means we have support for iterators. This is one example of an iterator. So just like in Java or C# or other languages, each object with a defined iterator is basically a collection. We have all the other common types like maps and sets and lists integrated into the language, and we have syntax for them, which we will see shortly. And this is one simple way to define an iterator. As you see, marked in red, we have symbol iterator method. It's a new way of assessing the new features of the language. Simple is an immutable primitive type, which is used to define unique values across the entire language. So I thought about this, and I didn't want to explain simples in more detail because they are a bit complex to explain on first reading. So, but actually they're not that complex. They're really useful. They are like similar to strings, but each time you define a symbol, it's completely unique across all of your entire application. So it's actually a way to provide the language with a way to define unique identifiers. So this symbol iterator is a unique identifier defined in compiler, which means that you write a definition of the iterator for this object. As simple as that. So what that means is that you have to have a next method. It's like similar to the interface in Java. You define that you need to have next method, and each time you use constructs which use iterator, this next method is called, let's say, in loops on each pass. So this is a simple next method, simple iterator, which simply increases, which simply iterates across the object. This is an example of usage of the previous object. So we have Fibonacci object, and we use it in a loop, which internally uses its iterator to iterate through all members. And when it reaches the 1000, it simply breaks. These are examples of common collections like maps and sets. They behave in expected ways, so it's pretty standard implementation of the most widely known collections. Additionally, we have a weak map and weak set. These are also similar to Java and other language weak collections. So what weak collections do is they do all the same things as normal collections, but they allow garbage collector to collect their keys when they are not used elsewhere. What that means is they do not have a strong reference. So even if they are part of this collection, garbage collector can easily collect them, and there will be no error and no consequence to the rest of the program. So as a direct consequence of this, weak collections are not enumerable and do not have size. Why they do not have size? Well, because we can return the size of the collection, but it can change before it is used somewhere, because garbage collector can meanwhile destroy the object and change the size of the collection. So it wouldn't make much sense. In weak sets, this is an example. We are adding object with data 42, but this object can be erased from the collection if data, the key of this object, has no other reference, and garbage collector can collect it anytime. Modules are a new feature in JavaScript. They are finally added as the property of the language itself. Before that, we had JavaScript frameworks that provided the same thing. So the most famous ones were CommonJS, AMD, Require.js, and so on. We finally have an integrated way to use packaging inside the language. This is the example. So it is pretty much pretty simple and pretty much straightforward to use. With the export keyword, we define a library. In this case, it's a function that sums two numbers. In the below example, we see the definition of pi, which is also exported inside this library. And in app.js, which presents the rest of our application, we simply use it with imports. So it's a standardized, well-known mechanism, and we finally can use we can finally introduce some order into our packaging and into our classes and avoid globals in a really efficient way. Promises are used for asynchronous programming. It is also a feature commonly present in in all major JavaScript frameworks. It is a first-class representation of futurely available value. So, what does this mean? We will see on the next example. Okay, so this function resolve under 3 seconds that accepts a delay argument will return new promise, which means it will have a value in some delayed time, and at that time it will provide set timeout with resolve or reject. Resolve or rejects are two callback functions which will be executed in case this promise is fulfilled or rejected. So here is the example where we run this function, and in the first case we chose 2000, and in the second case we chose 7000. So why is this other case rejected? Because this is the key marked in black comment. Once a promise is settled, its result can change. So basically we have 3000 milliseconds or 3 seconds to accept this promise, or it will be rejected. So in the first case we used an allowed interval, so it was accepted, and in another case it was rejected. Basically what we get with this is we can use asynchronous features, and we can return a synchronous value with which will be evaluated in some future time. So let's say if we use jQuery and we use an AJAX call, we can return a promise object and work with it like it was already evaluated, but we can write the rest of the code with that object, and it will be evaluated asynchronously. Okay, so these were the most interesting features of the language. And now about the future. So current browser support looks like this.
We could have some questions also in the meantime.
So this is the list of the features supported by various browsers. In the header we have browsers with described in various columns, and well, the most interesting part I wanted to show you actually was like this Chrome and Opera 36 and 37 column, where we see all fields are marked with green, which means that good part of the language is actually supported. So also, if you look at the Edge 13 also has a lot of support for new features. And it really looks good. It looks like in new versions of these browsers we will have finally support which is even better than if you look at the Babel column on the left, which we don't see right now, but we see, yes. So this is the Babel, and it still has some red fields, while Chrome, Edge, and Firefox 45 have the green fields. So that means that soon enough we will have really good support for ECMAScript 6.
Okay, we're running out of time, so can we have some questions, perhaps?
Okay, so there is also one other thing I wanted to say, and that is a 12-month release cycle in future versions of the ECMAScript. So each year we get a new release, and it's a fixed schedule, so we can count on new improvements of the language. And that was about all that is for today's lecture. If you have any questions, I'm happy to answer them.
Here's one. So there are like a few other features that you haven't mentioned, like generators and proxies. Can you maybe just give a little comment about those? They're really important features that came out with the new JavaScript language?
No time. I shouldn't explain them, but there is not an easy way to explain them without at least a slide. But yes, there are a lot of other features, and they are. I mean, there is a post like 350 bullet points, which describe all the new features in ECMAScript 6, and it would really take a lot of time to explain them in one lecture. So, but yes, I agree. Those are really important and nice and very usable features. Thank you.
Okay, thank you. Can we have a round of applause, please?